Let us see some problems related to combination. So let's assume a particular situation where I have to form a committee of 5 members out of 6 men and 4 women. So there are 10 people in all together. I have 10 people altogether. I have to form a committee of 5. And there's a condition that in committee there is supposed to be at least one woman is supposed to be there. So let's see how many ways, first of all, I can form the committee. So a committee can be formed in 10C5 ways. And when I solve it using 10 factorial divided by 5 factorial, this is the formula of combination which I'm using, and 10 minus 5 factorial. When I solve it, I get 252 possible committees that can be made. Now, since I need one woman all time on the committee, so what best I can do is the number of committees in which there will be no women. So if I'm saying, if I try to, so there are other ways also you can do that, but I'm telling you the easiest way. Let's assume when there is no woman in the committee, then in that case I'm left with the choice of 6 men only. In that case, I have to select all my members. In that case, n will become 6. So I'm talking about the case of now women, and R will become equal to 5 because I have to select all my committee members out of men. And that becomes 6 factorial divided by 5 factorial and 6 minus 5 factorial, and gives me a value 6. Now, since 6 committees can be formed in which there is no women, and total possible committees are 252, so number of required committees, or number of possible committees, I should have corrected, number of possible committees having at least one woman going to be 256. Total possible committees minus the committees which are formed without women, 6, and that gives me answer 246. Let's see another example. Find the number of ways a cricket team consisting of 11 players can be selected out of 14 players. So simply here I have n is 14 and I have to select 11 players out of 14. So you know how many ways the team can be selected. 14 C11 total possibilities. I've got 14 factorial divided by 11 factorial and 14 minus 11 factorial. When I solve it, I get 364. And now there are two cases will include a captain. So if the captain is already been selected, now I have to select only 10 players out of 13. So it is going to be 13C10 because out of 14, one player is captain who has already been there in the captain. So I'm talking about the case including the captain. And when you solve it, it's going to be 13 factorial divided by 10 factorial and 13 minus 10 factorial. You can simply expand it. 13 factorial divided by 10 factorial. 13 minus 10 is 3 factorial. Further, 13 times 12 times 11 times 10 factorial divided by 10 factorial, and it could be 3 times 2 times 1. You can cancel it out. That is going to cancel 2, and you're going to get 286 possible combinations. Let me do the B part of this problem where you want to exclude the captain. Now, if I want to exclude the captain, that means I'm left with 13 players. But in the selection of team, I don't put the captain in. So this time I'm going to select 11 players out of remaining 13. Same way you can solve it, and there are 78 ways I can select this particular team. So this is about permutation and combination. If you see all the lectures, that concludes this particular permutation and combination series. I probably try to keep on adding some practical questions. Thank you.